Hey and welcome. Today we'll be going through a Kubernetes security challenge number 2, provided by the awesome folks at the KodeKloud learning platform. And for this challenge, we have a number of applications that will be deployed in these 3 namespaces called prod, staging, and dev. There are a few security issues with these applications. We should inspect the issues in detail by clicking on the icons like this and complete the tasks to secure the applications. And once done, we should click on the check button as we did before in the previous security challenge to validate our work. Okay, I'm going to start with the Kubesec icon and let's see what tasks are there to be solved. So before we proceed, make sure to fix all issues specified in the Dockerfile web app section of the architecture diagram. Using the Kubesec tool, which is already installed on the node, we should identify and fix the following issues. Okay, so we actually have to start with the Dockerfile with this nice looking icon on the top left. I'm guessing we should edit this Dockerfile. We should run it as non-root, we should avoid exposing unnecessary ports, and we should copy the Dockerfile and other unnecessary files in the directories into the image. We should move the required files and directories mentioned in between the brackets to a subdirectory called app under web app and update the copy instruction in the Dockerfile accordingly. And as for our final task, we should rebuild this image locally with the tag KodeKloud web app colors table. Okay, so let's enter the web app directory first. This is where we have Dockerfile. And as required, there is no subdirectory called app yet, so let's create one. And let's move these 2 files, app.py and requirements.txt, and we have one directory also, and move this to newly created subdirectory called app. Let's check our work. Okay. Good. The files were being moved. So let's edit the Dockerfile now. I'll start at the bottom. I always start at the bottom when editing files like this for some reason. So we should run this Dockerfile as non-root, and we should use correct application user, which in our case is a user worker that we have here. So let's use this one. We should avoid using unnecessary ports. Exposing this port in this context is unnecessary because, as we all know, the port number 22 is being used for secure logins, secure copying, and secure FTP connections. We should also copy all files to a directory called opt from the a directory called app, where we move the 2 files and 1 directory before. Let's now rebuild this Dockerfile. I'm going to use this tag listed here, as this is what the task wants from us. So we should wait a little bit now, and then we'll check if what we did was being done correctly. There we go. The icon turned from red to green, so we can proceed. So with the Kubesec, we'll be using the Kubesec tool that's already installed. Yes, it's already installed. And we'll use scan command we'll be scanning these two files. So basically we have two files which are being used to deploy the dev web app pod in the dev namespace. So this, yeah, these two pods are already being deployed. Okay, let's check the files using the kubesec scan command now. And let's see, small typo, if there's anything that we have, and there is. There are some issues that need to be fixed. One is capability sysadmin is the most privileged capability and should always be avoided. And we also have allow privilege escalation, which should be set to false. Let's scan the other one. I'll explain briefly later on why these things should be changed, if anyone's interested in that. So yeah, the issues are identical, so we'll be changing three things in each file. We'll have to, once the pod is redeployed, which there should be a fix with the image called KodeKloud web app color stable. Yes. So we'll edit this on the go as well. Like this. Let's remove the sysadmin capability. Basically, this capability in Linux grants us a process excessive privileges, including the ability to perform potentially dangerous system-level operations. And this can be exploited by the attackers to gain unauthorized access and can cause harm to the system. So it's generally recommended to avoid granting this capability whenever possible. We need to set this to false as well. And setting allow privilege escalation to true, as it is set here by default, is generally considered a bad security practice because it increases the attack surface of your container. What it is, it's a field in a Kubernetes pod security context that controls whether a container can run with escalated privileges. When this field is set to true, the container can potentially escalate its privileges and gain access to resources outside of its assigned namespace or perform actions that could be harmful to the host system. So a little bit of theory behind why we're actually doing this for anyone interested. I know I was when I started dealing with these things. Okay, we should delete the pods before we redeploy them. So we have two pods in two different namespaces. So this is taking a while. So we'll be using the force option. There we go. Now let's see if we did everything correctly. And let's deploy these pods. And we made a slight mistake. There we go. Sometimes it's good to make a mistake or two, because then you're being forced to troubleshoot issues. And by troubleshooting, we learn a lot, at least I do. So, okay. We have a green light for the Kubesec tasks, and let's move on to the next icon, which is the web app and staging web app. And let's try to fix these issues. So these pods can be accessed using the kubectl exec command. We want to make sure that this does not happen. We should use a startup rope to remove all the shells, sh and ash, before the container startup. We should use the initial delay seconds and period seconds of 5. For this to work, you would have to run container as root. Okay, so in Kubernetes, a startup probe is a type of liveness probe that is used to determine when a container has started and is ready to accept traffic. So unlike a regular liveness probe, which checks if a container is still running, the startup probe is used to delay the startup of the container until a specified condition is met. So this can be useful, for an example, for applications that take some time to start up or that require additional dependencies to become available before they can start accepting the traffic. So let's try to exec into the pod and see and check for the shells. So as we can see, we have a shell called ash and sh in the pod. Let's exec into the pod number 2 as the task is nearly identical. Well, I think it is identical, it's just that they gave us the shell names here, but let's verify it. You can never be too sure with these things in Kubernetes. All right. So what we need to do is remove the shell executables bin.sh and bin.ash in our case, and we'll be using the startup rope for this. Okay. Let's see if we can get a correct template. We can use this one, the readiness probe, but it suits us because we need to specify the initial delay seconds as per task and period seconds and use the value 5. Okay, so let's do that. And let's change the readiness probe into a startup probe. We should edit these fields a little bit. I'll explain what we're doing shortly. In case anyone is interested. I think this is correct. So with this command section basically uses startup probe to remove the shell executables, bin.sh and bin.ash in our case, before the container starts by running the command remove bin shell bin.ash using the exec command. So the initial delay seconds and period seconds field specify a delay of 5 seconds before starting the probe and running it every 5 seconds thereafter. This basically ensures that the shell cannot be used to access the container. Okay. Let's try and deploy that now. There we go. And let us do the same. Yeah, the pod was being successfully deployed. I'll just copy the same. Start a probe template. And we'll be using it for dev web app pod also. There we go. Oops, I deleted the wrong one. My bad. There we go. As I said before, it's sometimes useful to make a mistake or two. That way, either you get better at troubleshooting or more proficient with it. But as long as you're not creating too many mistakes in an actual, especially production environment, this is still a sandboxed environment where we can afford to make mistakes every now and then. Let's check if what we did was correct. There we go. Not only one, we got 2 green lights. Pretty awesome. Okay, let's move to the namespace prod. What we have to do here is deploy a network policy, and we also we have a deployment that has a secret hard-coded. Instead, we should create a secret called proddb for all the hard-coded values and consume the secret values as environment variables within the deployment. So we'll have to define all the secrets data as container environment variables, but first let's check let's take a look at the hard-coded secrets within the deployment called prodweb first. There, this is how we get these values. And let's create a secret using this value now. Yes, there, let's do that. Secret is called proddb. There we go. Let's now add the deployment. We won't be needing these hard-coded values because we'll be using the a secret called ProdDB. And specifically, we'll be looking for, let us find the right template. We'll be using env from to define all the secret data as container environment variables. So let's use this. Our secret was called ProdDB. Okay. Let's check if our work was correct. There we go. So this task is also solved. And we have the last one, which is we should create a network policy called prod netpol that will only allow traffic only within the prod namespace. So all the traffic from other namespaces should be denied. All right. So I'm guessing this will be using an ingress type of rule for this network policy. So let's copy. We won't be needing ports. We'll be needing namespace selector. So let's check what the labels are of a namespace called prod. There we go. These are the labels. We only have to allow the traffic from within a prod namespace, so there isn't any, we won't be needing any pod selectors, so we should select all pods in the given namespace. And the name is called, and the namespace is prod. There we go. Let's create this network policy and let's check if everything is done correctly. We should be close to solution. And this is it. We are complete. This one was quite tricky, but also challenging. Thank you for this. Thank you for watching, and I'll see you in the next challenge. Bye.